So hello once again. So in this video I want to just implement the unimplemented function that I showed you in the sixth tutorial, which is join a room automatically. Just be specific, join available room. So this function is located on the local client remote matchmaking, but it's joining an available room by accessing a Redis server directly, which is not the way it should work. So all the operations regarding the matchmaking should be happening on the server side. So now we'll be trying to port it from the client to the main.go. So as for the start, you should just take the whole thing, and port it to somewhere here. So for that, we should specify a new endpoint, gin endpoint. Let it be so join and available. Let's give it a name, a little comment. So let it be post matchmaking join available. Let's create a gin endpoint handler. Let's call it just join available one. At the bottom, join available. So gin handlers, gin endpoint handlers, they accept gin context as the argument. So should pass a gin context. Let's pass the whole operation here and try to tweak around the join available room. So first we'll be trying to implement the join available room on the server side, and we'll be making an appropriate set of operations on the client side to make calls to the server side for automatic available room joining requests. So first we port the packages needed for the function. So let's get rid of this return things. Let's just instead return JSONs. HTTP bad status bad request GenH. So GenH is an override for the type string to string map. So map string to any. So let's say error. Let's pass the error. Let's pass the actual error message from the error. And you know what? So I would rather say this. That's better. And return. Do the same thing here. So let's return the error message saying that couldn't convert the maximum players to int. The same thing, the same technique in here. We return a JSON object by saying that there are no rooms available. Just return, and for join room it's actually inappropriate. So for that, so join room in our case it's another gin handler, gin endpoint handler. So for that we'll just pass in the, just remember the property. So room ID, dynamic port, right address. So for that we'll pass the context. So it doesn't return anything, so just get rid of the return statement and return the JSON exactly the same way. So in here, so as a return statement, we should probably return the room ID, of a room that the client was connecting to. The room is automatic. So we should get the room that in a sorted set. So we should figure it out. So room key, we get the room ID in here though. So we can simply say HTTP let it be status OK. H say message the successfully joined. Let's pass the ID. So room ID. Let's pass the room ID. So this in case of all the other statements are valid without errors. We join a room. So it's checking the error, which is another thing. So in our case, just it's actually an issue. This join room doesn't return anything, right? So if there will be some problems, we'll just return a message from the join room. Just return it here. So I would actually it's the pointer. I think we can do something like error. Not sure about property. Does this the that's not the thing. Yes. Okay, so I think that should be okay. So we can say that if thing errors dot none of errors is not nulls, and we can just return that something happened. Because we are passing the see the context as a pointer, as an address of the context to the join room. We have the access to see later on. So now getting a room key, current players, maximum players. Current players is greater than, alright. We're trying to join. So in here we'll be passing the. We should delete the RDB client. Any RDB accesses should be on the server side. So we're sending the dynamic port and RPC address. They were using here dynamic port and the RPC address. Dynamic port is a client ID and the RPC address is the RPC address. So, all right. So, current players. ORS. So let's define a type. Request data. Let's define a struct. Say, I think we define it somewhere here. Something similar. So yes, client ID, RPC address, room ID, client name. Yes, exactly. This is what we need. So we'll be passing the room ID. So initially, we're passing the client ID and the client name actually. The client ID and the client's name. RPC address. So it was the dynamic port and the RPC address. Okay, so we're on the right track. Then we have to bind the body to the object, to this request data struct. So we can do it this way. We can use operation of composition with C should bind JSON. We can pass the address of request data, compose it with error. It's not null. Check whether it's null or not. Return the JSON in case the bad request happened. Status bad request. And error. Can say something like uh, couldn't bind object error error. So now we're trying to bind the object, the body, to the request data. So after that, after we bound it to the request data, we're doing the following. We're getting the so that's fine. So for now, so I said we need the room ID, client ID, right? So we need, where is this thing? Okay, let's just remember. So I think C has context. The context has function called set, if I'm not mistaken. So we have the room ID, we have the client ID, we have the RPC address. What is this? Did I use it somewhere else? Addresses, it's inappropriate. RPC address. Okay. So we have our client ID and the RPC address. So we can now set the client ID and the RPC address. We can bind the room ID now. And the room ID will be this room ID that we found above. So here we're sorting actually when we create our rooms, we sort them by score. So we get the so in here we get the room with the minimum amount of current players. We find its room ID. So we found it this way. So we split the rooms are set in this format. So like with semicolon with the key on the left side and the value in the ID on the right side. So we just get the ID. We converted it into int because the IDs in the Redis server are processed as ints. So we set up our room ID and we set up our client name. The client name. The client name I think is not in here. So the client name is RPC address. So it's also a little bit messy. Client ID is RPC address plus client. I think it's plus. Wait. It's RPC address plus client name. It's basically request RPC address plus request data client ID. That is, what's the problem with it? Filled. Most of them are str a. We're converting integer into string, but no, it's I don't like this. Let's make it this way. %d. That will be much more organized. So having all this summation operations. So alright, we set up our, what's the problem now? Why is it warning us? Turning results. What? Yes. Okay, so we both the client name and the room ID, and we're passing the C to join room. So it should be okay now. So what we're doing, we're passing, let's go from the beginning. So we're getting our client ID RPC address from the body of request. So then we bound it to the request data. Then we find our rooms in increasing order by the lowest amount of current players. So pass, we set up new keys such as room ID and client name. Don't need that. So now pass the context to the join room. Join room will then join to the room with the room ID to join the client name. Join the client to it. If we go here, it's you see client name. Client name. Oh, it's joining it here this way. That's another issue. We don't need to specify it this way than client name. It should be just I think it should be just client ID. That's another thing. Client name, client ID and RPC. So RPC address. So it's accepting the client name. So we need to specify our client name as well. Apart from the ID. Client name. Let's do it. JSON. Here's the thing. Okay. What's the problem now? Update the client name. Okay, so we're sending the context to the join room, the room ID, client name, then this client ID along with the RPC address, the join room. It's joining, and it will be joining our player to our client to the phone room, so it should be okay. Now let's go to the client side. Where is our join available room? The endpoint. Now we'll be making a request to our endpoint. Matchmaking join available room. So our request URL will be this. So this is the address. This is the address of our matchmaking service. So host token internal means that the DNS, so this actual DNS of the running server, DNS of the Docker cluster. So the DNS of the Docker cluster has the access to all the local IPs defined on your machine. So we're specifying it. That's why we're specifying it this way. I'm just not sure about the HTTP part. Yes, we should specify that makes sense. Then the payload. Payload, we can just specify whatever the load our join available room is expecting us. To send client name, client ID, we can send the payload in here. We can initialize it in here. Client name will be our client name. I think it's defined. Client names and our client ID also, I think it's defined. Nope, it's not defined. ID. So let's keep it this way. My RPC address. About the client ID. Client ID is it's our dynamic. Yeah, it's our dynamic port. So that's okay now. Now now we need to take this payload and convert it into bytes. So it's a function JSON Marshall. Send the payload. Send the payload. It returns the byte and error. So data error. We can check the error. So if it returns error, we can just return -1 and some error. Yes. I think error S error, doesn't it have S error? Error, oh yeah, it's error F. So I shall take this thing and just copy to save time. So we have our data. Now we need to make a request to to our endpoint, which is post. Post, our URL will be this request URL. So we need to send the payload. Bytes buffer. We need to put our data into the buffer. So the post will also, why it's not defining. Yeah. It's accepting, as you can see, I add the content type. Application JSON. So it's accepting the URL, content type, and body as IO reader. So basically, we're defining our IO reader by specifying, by passing the data into the bytes buffer. But why is it? I think it's the problem. So that should be okay. That should be fine. But maybe it's a new buffer. Yeah, it's a new buffer. This one creates initialize a new buffer using buff as initial contents. It creates our buffer. So also we need to take our response, the error, response error. Also check the response. We should close it by the way at the end. Rest close, body close. So that should be okay. So we have our response now. We defer the closing of the body. So we pass the client name, client ID, RPC address, and now we should, let's just follow the pattern. Let's check the status code. Then try to parse the body. Status code is status OK in our case because we're returning the OK at the end. Status OK. And we're returning the message in the room ID. Room ID and the message. Yep. So return, so -1. Happened during the response body reading. Okay, so here we're reading the body of our response. Body for response. We're then unmarshalling the body, which is a set of bytes, a list of bytes into our rest body. Also here, check goes through the error checkpoints. If everything is okay, we got our message. We can simply return the message, room ID in the error. Let's do it this way. Let's just specify our room ID here as an int. Then just assign the room ID to the rest body room ID. Return our room ID in here was nil. So that's the fix. It shows some errors where. Where's the problem? Here. RDB. So that was the change. So let's go through it again. Join available rooms. So we ported the whole functionality of join available room that was making direct requests to the RDO to the Redis server, that was changing the state of the Redis server. So we just transferred it to the client side, to the endpoint, to the Gengonic endpoint join available room on the specified endpoints. So here we're accepting the client name, client ID, RPC address. We're finding our available room ID. So then we append room ID and client name to, and we can delete the client name. We're appending our room ID to the context, and then we're passing it to the join room. So we have our client name, client ID, RPC address, along with the room ID, client name, RPC address, room ID. So we're joining a room that was found on the join available function. If join was successful, we just return the message. We're returning JSON saying that successful join room, and we pass the room ID as the second property of the returned JSON response. So here we're also doing the following. So we're specifying our request URL, which is a composition of the Docker DNS and the ports that our server, the matchmaking server, is running on, is 8095, 96, 96. We should fix it. 96. So we're creating our payload. We're passing in the client name, the our client name, the dynamic port that was allocated during the local client initialization, RPC address of the client. So then we're marshalling the payload into the set of bytes, list of bytes. So then we're passing the list of bytes data to the new buffer as a body of our post request to the request URL. We defer our response body close using reservoir checking errors. You can also check errors in here. Say yes. RF error during the request processing. The error is error error. Then we defer our body close at the end of the process. So this defer means that the response body close will be closed at the end of the function. So then we just get our assigned. So we initialize our room ID. We check whether the status of this request. This request is OK, is 200. Whether we reached that part of the endpoint. If so, then we just create our response body, the body that will be loading our parsing our body into. We're reading the whole body into the body list of bytes. Then we check the error, whether it has errors or not. So then we marshal the body, the whole body into the response body struct. Check errors, and we assign room ID to the room ID. Can also do something with the message, but currently we don't need it. Return the room ID. No. So that was our join available room function transferring to the main go. I hope it just gave you an idea of how transfer should look like. I mean, now as you can see, there are no RDB requests, nothing. So I'm just wondering, was there some other on RDB related stuff? Redis server. Where do we use it? So Fatal server, we don't need it actually anymore. We don't need to parse it. Don't need to parse that part. It's deployed, remote, it's appropriate external. That's where the server also should just delete Redis server. We don't need the RDB. The client here, we're initializing the Redis client. We don't need it. We don't need it anymore. Choice handler, we don't need it. So where is this RDB in here? So that should be fine. That should be fine now. Also here, the leave current room. We also have the leave current room unimplemented. So I'll record another video for that.